Okay, so the topic of this lecture is basically regarding to the international conventions uh, for the controls and management of sea ballast water and sediments. So bearing in mind that the convention is not only relating to the sea ballast water, but also how to treat the sediments. Yeah? Some of you may not really not yet knows the convention. Therefore, I will like to explain to you in a little bit details how the international conventions regarding to the ballast water and sediments is carried out. So the outline of this lecture is introductions, then proposed regulation contents and conclusions. So before we are continues to the lecture, at least you know uh, the the overview of the ballast water. So this is a quite very interesting video.
The 8th of September 2017 marks an important day both for the shipping industry and for the environment, because this day is the entry into force of IMO's Ballast Water Management Convention.
The spread of invasive aquatic species in ships' ballast water has long been recognised as a major environmental threat, and this convention addresses it at the global level.
So what does it mean for ships?
From the day this convention enters into force, all ships engaged in international traffic must manage their ballast water so as to avoid the introduction of alien species into coastal waters. For most ships, that means either exchanging their ballast water or treating it using an approved ballast water management system.
Initially, there'll be two different standards corresponding to these two options.
The D1 standard requires ships to exchange their ballast water in open seas, away from coastal waters. Ideally, this means at least 200 nautical miles from land and in water at least 200 metres deep. By doing this, fewer organisms will survive, and so ships will be less likely to introduce potentially harmful species when they do release their ballast water. D2 is a performance standard which specifies the maximum amount of viable organisms allowed to be discharged, including specified indicator microbes harmful to human health.
From day one, all ships must conform to at least the D1 standard, and all new ships to the D2 standard. By 2024, all ships, new and existing, will have to conform to the D2 standard. For most existing ships, this involves installing special equipment, so there's an implementation timetable for them based on the date of their IOPPC renewal survey. But implementation of the convention actually begins straight away.
For example, all ships, new and existing, must have a ship-specific ballast water management plan and an International Ballast Water Management Certificate issued by or on behalf of their flag state to confirm their compliance. Not only that, all ships will also have to carry a ballast water record book to provide evidence that ballast water procedures have been carried out correctly. And all ships will be subject to inspections by Port State Control to confirm compliance, which may include actually sampling a ship's ballast water as well as inspecting the documentation.
So what does this mean for the environment? Well, it's good news, and again, from day one. The requirement to exchange or treat ballast water applies to all ships immediately and without delay, which means something that's been identified as a major environmental threat is being actively addressed, and IMO has delivered another significant milestone for the health of our planet.
Okay, so those are basically the overview on the ballast waters uh, management convention, how it will be conducted. So if you have a look the background, Why it is very important? Uh, the shipping is moved over 80% of the world's commodities and transfers a- approximately 3 to 5 billion ton of ballast water internationally every year. So it's quite a very big or size of the ballast water. And the second one is basically the ballast water is essential to the safe and efficient operation of shipping, but it also poses a serious ecological, economic, and health threat to the transfer of invasive aquatic species inadvertently carried in it. So ballast water is basically very important to the ship because it will be make a stable on the ship. On the other hand, the ballast water also pose a serious ecological. So therefore, it is necessary to make some treatment. One of the way first, as I mentioned previously in the video, that the first is conducting the ballast water exchange, and the second one is a ballast water treatment. If you have a look this one, there is some possibility way where the ship have to be uh, moved in the world. If you have a look this one, it's possible to move from here to here, and to here to here, and to here to here. Yeah. If you have a look, this is some figure shows that the major area with invasive marine species. And uh, if you have a look this one is from north to the west, for instance, yeah, north to the west, like this one, right? From the north to the west. So if you see this one, there are some major area with invasive marine species. This is the figure. If you have a look this one is some area in Europe, right? And there is some small number of invasive alien species in some country, like this one. So it is very important to prevent the spread of harmful aquatic organisms from one region to another. Then um, how the ballast water is basically uh, what is the purpose basically for the ballast water? First is maintain safe operation condition, right? Then second one, stabilize the vessel, yeah. For instance, providing transfer stability. And another issue is reduce stress on the hull, because when the hull there is no any ballast water, then it will be very dangerous. A ship is basically a look like a beam. Yeah. If there is, for instance, this is the figure, for instance. Yeah, this is the figure. If there is no any one, if there is no any water inside to the ships, yeah, like this one, right? There is no water inside the ship, then it will be very dangerous because a ship will get some, how to say, some force, like a hogging and sagging. So it's very important when a ship is getting a sagging or hogging, like this one, it's getting hacking and sagging, and there is no any ballast water inside, or there is no any cargo, then will be very dangerous to the strength of the hull. Therefore, another purpose is reduce the stress on the hull. And another one is improve propulsion and maneuverability because relating to the immerse on the propulsion. Okay. And another problems, ballast water also in this case is pose serious health problem, then pose serious ecological problem. Another one is pose a serious economic problem, and many problem may occur due to the biodiversity. So if you see this figure, yeah, this is the cycle, yeah. When a ship in the port, yeah, in the port, right? If you have a look at this one, when a ship in the port and loading a cargo, yeah, loading a cargo, then a ballast water is discharged, yeah. Then later on, move to another port. A ship is discharging a cargo. When a ship is reached to another port, to the destination, then a ship shall discharge a cargo. When a discharging a cargo, a ship is a condition empty ship. It's not carrying any cargo. In that case, when a ship is not carrying any cargo, then a ballast water is loaded. In this case, there are so many species enter to the ballast water tank. Then later on, in this case, is transit in ballast, then go again to the another port and loading a cargo, then discharging uh, the species. So when a ship is goes to another country port, then the problem may arise that uh, the species will be introduced to another country. So it will be very dangerous in that case, right? So this one is how I explained you before, and the source port cargo is unloaded, ship takes in ballast water, unloaded, then ship takes a ballast water. Then during the voyage, after cargo hold is emptied, ballast tank are full, then goes to the destination port. A new cargo is picked up by the ship, then ballast water expels. So in this case, there is some introducing the new species to another port. On the return trip with a full cargo, then blast tank are nearly empty. So this case, because it's a nearly empty tank, because its cargo hold is already full, then the ballast water is nearly empty in this case because it's already discharged. So that's why it is very important to treatment the ballast water before discharging. Okay. Okay. So how is ballast water is implemented in this case? Okay. So the ballast water convention is applied to all ships, yeah, including submersible floating craft and floating platform, uh, floating storage unit, and FPSO, floating production storage offloading. So in this case, it means that all ships shall implement the convention. If uh, if the a country or the flag state already ratified to Ballast Water Convention. Then the second one is ship not designed to carry ballast water. Right? This one is not implemented to ship not designed to carry ballast water. And the second one, ship not operating in international water because ballast water convention is basically for a ship with its goes internationally. Then third one, warship, naval auxiliary ship, or other ship owned or operated by a state. The fourth, ship only on non-commercial services. And the last one, ship with permanent ballast water in seal tank. I mean that the ballast water will is not necessary to be discharged. So it means even it is water, but it's sealed. Seal means that it's not discharged to another places or another port. Then it is in the convention is implemented to ships entitled to fly the flag of a party. What it does it mean? Flag of party means that the flag state on the state which is already ratified to the convention. To the convention means is a ballast water convention. And the second one is ships not entitled to fly the flag of a party, but which operates under the authority of a party. It's mean when a ship operated to the party of a state which are the party of the convention. I mean, the state which are the parties or ratify the convention. State the, that ship shall follows the International Ballast Water Convention because a ship shall follow the regulation of a state. Okay, and the ship is not designed or constructed to carry ballast water. So it's mean that if you have the cross mark here, is it means that it's not necessary to be implemented to ship not designed or constructed or carry ballast water. Or the second one, ship or a party which only operate in water under the jurisdiction of that party, unless the party determine that the discharge of ballast water for such ship will impair or damage their environment. So this one is uh, it's not necessary to implement. Okay, let's say for instance, um, the second sentence in this case, ship of a party will only operate in water under the jurisdiction of the party means the ship which operated domestically not or nationally, it's not internationally. Let's say when a ship operated from Surabaya to Jakarta, and the national regulation said that it is not necessary to comply with international regulation or ballast water convention. So the ship is not necessary to follow the convention or to comply with the convention. And the another one that ship of party will only operate in water under the jurisdiction of another party. Okay, so this one is some exemption for the ships. The another one, ship which only operated in water under the jurisdiction of one party and on the high sea. So in the high sea, it's not necessary to implement the convention. Then any warship, naval auxiliary, or other ship owned or operated by state and use. And another one is not necessary for ship having permanent ballast water in seal tank on the ship. Already explained you before. Okay. Instead of the application, this one, instead of the application, uh, the each party also necessary to provide sediment reception facilities. Why it is necessary? necessary to provide sediment reception facilities because when ballast water is taking in the ballast water tank, it also there is a sediment inside the ballast water. Yeah. Therefore, the convention is not only regulates the ballast water. It's not only regulate the ballast water, but also the sediment of the ballast water. So if you see or if you read this convention, it said that each party undertake to ensure that in port and terminals designated by that party where cleaning or repair of ballast tank occurs, adequate facilities are provided for the reception of sediment. So in this case, is adequate facilities are provided. And there is some requirement, okay? There is a requirement. Such reception facilities shall operate without causing undue delay, yeah, undue delay to ships, and also shall provide for the safe disposal of such sediment. Okay, this is the requirement. So the content of the Ballast Water Convention, there is A, B, C, D, E, F. So A, B, C, D, E. Yeah. The section A is general provision. The section B is management and control requirement for ship. Section C is special requirement in certain area, and there is standard of ballast water management. And also there is a survey and certification requirement for ballast water management. So this is some general provision. Uh, there is some regulation, definition, general applicability, exception, assumption, equivalent compliance. So in the regulation B1, for instance, it mentioned that when a ship already comply with the convention, the ship are required to have on board and implement a ballast water management plan. Yeah, a ballast water management plan approved by the administration. Administration in this case is flag states. Yeah, flag state. So in Indonesia is Ministry of Sea Transportation. And in regulation B2, ship also must have a ballast water record to record when ballast water is taken on board, circulated, or treated for ballast water management purpose and discharged into the sea. Then section B3, the specific requirement for ballast water management. Yeah. And section B4 explain ballast water exchange requirement. So if you see previous video, it's very clear that there is two treatment, right? Ballast water treatment and also ballast water exchange. Ballast water exchange is are usually called in D1. Then ballast water management, sorry, ballast water treatment is usually called is D2. So there is a different. So in the standard of ballast water management, yeah, there is some performance standard. Uh, Regulation D1 is ballast water exchange standard. Ship performing ballast water exchange shall do so with an efficiency 95% volumetric exchange as ballast water. So there is a requirement, right? Previous video said that in 200 nautical miles, at beyond 200 nautical miles, and in 200 meter depth, yeah, of the depth on the water. Regulation D2 is relating to ballast water management standard. So ship conducted ballast water management shall discharge organism and discharge of indicator microbes shall not exceed the specified concentration. How is possible to discharge with the specific concentration? So there is some treatment. I will explain you before later on. Yeah, this is some organism category. The plankton is more than 50 micro. This one is shall be less than 10 cell every cubic meter. Then the plankton 10 to 50 micrometer. Like this one, the size is less than 10 cell every 1 millimeter. Another one is toxiconic Vibrio cholera, Escherichia coli, then this one, Escherichia enterococci. Yeah, this is some requirement. Less than one colony forming unit or CFU every 100 milliliter or less than one CFU per gram. Escherichia coli less than 250 colony forming unit every 100 milliliter. Then Escherichia enterococci less than 100 colony forming unit every 100 milliliter. So this is the requirement. Therefore, before a ship is discharged, I mean, when a ship is discharged, the ballast water shall meet this requirement if conducting ballast water treatment, right? If the ship conducted ballast water management, it's not ballast water exchange. Then this one is ballast water management system must be approved by administration. So in this case is uh, flag states. Then and regulation D4 cover prototype ballast water treatment technology. Then under regulation D5, so review of standard by the organization is IMO is required to review the ballast water performance standard, taking into account a number of criteria, including safety consideration, then environmental acceptability. Okay, so this one is some survey and certification requirement, some some information regarding to certification. Okay, I will pass this convention. So if you see this one, the International Convention for the Control and Management of Seaborne Water and Sediment, BWM, is adoption in February 13, 2004, then entry into force September 8, 2017. So it's around 5 years ago, right? Sorry, 4 years ago, already entry into force. So when a convention is already entering into force, then eventually majority of the flag states ratify the convention because already implemented. So this is an example of treatment process if the ballast or D2 is conducted. So this one is physical solid liquid separation. There is a chemical enhancement. So there is a coagulation or flocculation. Then there is some treatment is possible utilizing hydrocyclone or surface filtration. So it's filtered, the water is filtered. So this one is disinfection. So there is a two-step, this one. First is physical solid liquid separation. So the sediment is already spirited, yeah. And the second step is disinfection. So there is many uh, treatment. It's possible utilizing chemical treatment or it's possible conducting the physical treatment. Yeah, chemical treatment, for instance, is possible utilizing chlorination, electrochlorination, ozonization, and so on. Then physical is possible UV irradiation, UV plus TiO2, possible deoxygenation, gas injection, ultrasonic treatment, cavitation, heat, or pressure vacuum disinfection. So if you see this one, there are so many technology already offer to treatment the ballast water. But bearing in mind, there is two step have to be conducted. So it's not possible only one, but the liquid spiration, solid liquid spiration shall be conducted, because as you know that the treatment is not only for ballast water, it's ballast, not only ballast water, but also the sediment of the ballast water. Okay, so this is some the treatment process. Yeah, so this one is the filtration. This one is filtration. Okay, dirty water in, then filtration, then clean water out, and this one is underflow containing solid inlet. This one is some pack, then underflow containing solid is here. So the clean water is overflow in this case, and this one is also UV tube and system. So the UV itself is inside here, then water is come in, then the ballast water is come out. And this one is some treatment process. Yeah, if you have a look, this one from sea chest, then the two ballast pump, then entry to filtration system and the treatment system. So the concept is basically make some spiration from the solid and liquid first, then later on is make some treatment. Then this one is later on to the ballast tank. There is also another step like this one, ballast pump, then filtration system, treatment, right? This one. So the clean ballast water is mean that with is already treatment is possible to the discharge, right? Like this one, it's going to the overflow. Okay. So this one is the step of when the ballasting, and this one is deballasting. So when from the sea chest, the sea waters come to the ballast form, then goes to the filtration system, then treatment system, then goes to ballast tank. Okay. When conducting the ballasting, it means that the ballast water from the ballast tank, yeah, from the ballast tank is goes to ballast pump, then it's possible to goes through here and overboard, because the ballast water is already clean, right? Because the ballast water is already clean. Okay, so it's only necessary to be overboard, because already treatment by filtration system and treatment system. So this is some process. This is some solid liquid separation. There are many methods, right? Benefit and considerations. So the filtration is generally using this or fixed skin with automatic backwashing. Backwashing means to clean the filter basically. Then effective for large particle and organism. Then maintaining flow with minimum pressure drop require backwashing. So if you are using filtration, it is necessary to backwashing. The backwashing means that the water is the filtration, the filter shall be clean by the backwashing of the water. Okay. So the mesh size are proportional to size of organism filters. And this is the hydrocyclone. This is the method is high velocity centrifugal rotation of water to spirit particle. Then benefit is alternative to filtration and can be more effective. Then effective only for large particles. Yeah. Then effectiveness depends on the density or particles surrounding water. Yeah. This one is coagulation, is basically optional pre-treatment before separation to aggregate particle to increase their size. Benefit is increasing size of particle, increasing efficiency of filtration or hydrocyclone separation. But there is some consideration may require additional tank space to store water, because if there is some coagulation, then the particle will be make very solid and getting bigger. So the sediment will be getting bigger. Then ballasting flocculation usually ancillary powder or magnetic or sand to help generate flock with settle more quickly. So this is some method we have to be taken into account. So if you are utilizing coagulation, you may require additional tank space to store the water. And this one is for disinfection. There is a chlorination, electrochlorination, ozonization, chlorine, parasitic, and hydrogen peroxide. If you see this one is a chemical, yeah. Uh, Normally well established and used in municipal and industrial water disinfection application. Uh, and a chlorination as the chlorination, yeah. And this one is for ozonization is especially effective at killing a organism. And there is a chloride dioxide effective on all microorganisms as well as bacteria and other pathogen. It also effective in high turbidity water as it does not combine with organism. Then there is also a parasitic acid and hydrogen peroxide, uh, infinitely soluble in water, produce few harmful byproduct and relatively stable. So if you see this one, is basically um, there are many optional, yeah, and there is some also another uh, methods for treatment of the ballast water. For instance, menadion, and there is also physical disinfection, ultraviolet, deoxygenation, cavitation, or pressure vacuum. Uh, but you see in this one, we have to take it into account whether it is possible to clean or not. So bear in mind, previously explained to you that uh, the ballast water management, or in this case the treatment, shall be two combination. So it's not possible only one, only physical disinfection only. Bear in mind must be there is two system have to be implemented: solid liquid separation and disinfection. Because as I mentioned before or explained you before, that there is a sediment inside the ballast water. Okay, I think that's all the presentation. Uh, any questions?